Hello, everyone, and welcome to today's episode of 𝗂𝗵𝗶's webinar series Tech Bites, where we regularly invite industry experts to share different insights into relevant topics. And I'm very glad you're here today, because today we're talking about a topic that some of us are sitting with for quite a while now. And I'm very happy to welcome Sia today, who's an ISAQB trainer at 𝗂𝗵𝗶 and is going to talk about something that he calls the architect's mindset in an agentic world. And I promise you, it's not another talk about how AI is taking over our jobs. It's something a lot more interesting and deep than that. It's something about what happens after the agent ships, about what the demo looks, if the demo looks great, and then 3 weeks later, something breaks and nobody really knows why. And yeah, all of that. So grab your coffee, get comfortable, and see it over to you.
Thank you, Clara. Hello, and thank you for being here. So, what the AI agent doesn't know, what it doesn't know. This is actually the conversation we need to have right now. Not should we use the agents? Clearly, we are using them. And also not, are they smart enough? Yes, they are incredibly smart, smarter than us at certain things. And I say certain things. The real question is that we need to ask ourselves, are we wise enough to use them well? Are we asking the right questions before the code ships? And more importantly, are we protecting what actually matters? That is what we are going to solve today, I hope. All right. So let's start by a story. Let me tell you like a story I got from a friend of mine. So they have a team, of course, smart engineers, good people, and they are definitely using AI agents to build features. So they built a feature over the night. It was extremely fast. By the morning, the code was done, test passed, the demo looked beautiful, and everyone was impressed. And they are definitely celebrating, and of course, they were happy. However, 3 weeks later, something critical broke. Not a small bug, something extremely important, which is affecting like the payment service, and of course eventually it's affecting revenues. So they starting investigating and the logs, the traces, and etc. And the strange part that happened here is nobody could figure out why it happened. The code looks correct. The logic was okay, but something was wrong. Something they cannot see actually. And of course, they went back to the AI agent and they asked it, "Why did you make this choice?" Of course, there were no answer, and the agent has no explanation. It just did it. So they spent 2 weeks. This is per his story. 2 weeks fixing it, debugging, and this is actually lost time. And the whole time, the real problem was not in the code, and that's a little bit frustrating. However, in this situation, I must tell you that the real problem was not the code, was not the AI, was nobody asked the right questions before the AI ran. Nobody said, "Wait, before you build this, what you are assuming? What could break like in a year, 5 years? What do we need to protect, etc., etc." They just let it go. So here is what I want you to understand. This is not an AI failure. Don't put everything on the AI. This is the human failure, actually. The agent optimized for completion. It did exactly what you asked, but nobody optimized for consequences, for what comes after, for what could break. The agent said, "Here is the code that works." Nobody asked, does this decision lock us in? And of course, they will suggest plenty of like cloud providers, etc., etc. Does this assume something that might be wrong, or more importantly, what happens in 6 months? And sustainability is key here. So the gap, that is where the problem lives. That is what we are going to discover today. All right. I want you to think about something here. It's a question for all of you. When was the last time a tool, could be an AI or any tool, made a decision you didn't notice? Of course, not a crash, not something you could see, a quiet choice, something that shaped how your system works today. You probably just thought about something. Please share that with us in the comment. Maybe it was like how data is stored, maybe how a component connects, maybe it was why library was chosen, etc., etc. And you thought, why did we do it this way? And of course, nobody has a good answer. Please like share your thoughts in the comments, and we can discuss this later. And actually, here, because this is exactly what's happening with AI agents right now. The agent is making 200 decisions probably today, and you are only reviewing three. The other, like almost 200 decisions, they are just there in your system, shaping how it works. And the question are they good decisions, or will they break? And you probably don't know that yet until they break. All right, let's talk about the agent. Let me explain you why what the agent is actually is. So your AI agent is definitely brilliant. It can recognize patterns you would miss. It can write code faster than humans. It can optimize for performance. It can solve hard problems. And it's legitimately smart. So we must confess. However, it's completely amnesic. Every time it runs, it starts from zero, blank slate. It has no memory of why you built it this way. It does not know about the decision you reversed last year, and it does not know the rules nobody wrote down. And more importantly, they don't think about the system fail in 6 or 1 year, right? So the agent sees your prompt, your code files, your stats, your current tasks. The agent looks at all of this and thinks, okay, I understand the problem, let's solve it. What the agent is blind to, why you built it this way, not the what, the why, the decision you reversed, the approach you tried then that failed, the rule nobody documented, the constraint that is in the code, the thing that will break. And this is actually the trap that you will about to walk into. Here I want you to like absorb that this is the gap. The agent is working from incomplete information. And when incomplete information is the foundation, the whole thing becomes shaky. So the question is, how do we give the agent the information it needs? How do we make sure it understands the constraint? And how do we become responsible for the decision it makes? That's what we are solving now. And you can think about an AI agent as an intern who is extremely smart. So if you don't give them the right rules and guidelines, they will do correct things, but not intentional that solves the real problem you have at hand. All right. So let's start with the move that changes everything. So the old job is we hold, we hand a diagram to a developer. Here is the architecture, describe, and we describe the structure and hope that execution will follow on that. You know how this works? You draw it, you build it. Sometimes they understand your vision, and sometimes they do not. So the new job is tell the agent what is forbidden to decide alone, set the rules before it runs, and turn into a constraint, and of course, not a hope. This is not only applicable for agents or for AI world, it's like the difference between classical architecture, software architecture, and the modern architecture. So you just give the rules and guidelines, and that's exactly the part, the most important part in the definition of software architecture. Uh, and you can see here, this is a fundamentally different thinking. So before you were saying, here is what I want you to build. Now we're saying, here is what you are not allowed to touch. Here is the lines you cannot cross. And here is what could break the system if you got it wrong. And that changes everything actually, because when you define the boundaries, suddenly the agent has directions. Instead of do whatever works, it is do whatever works within these constraints or boundaries. And that's a real instruction. And that's called accountability. So I believe now we understand this is not a small shift. This is how you go from being anxious about AI to being confident about AI. Because you are no longer hoping it makes good decisions, you are defining what good means. And this is not applicable only for software architecture or dealing with AI. Like definition of good or good enough is the most important thing in defining the problem you want to solve. So you have to, of course, the other most important thing now we are taking responsibility for the outcome. And let me be clear: this is not a skill. This is a way of thinking, and of course, it requires practice. It requires discipline, etc. All right. And now I'm going to give you four skills. They are not fancy words. These are survival skills, actually. You're seeing the first one in the slide, but I'm about to explain all of them. So, in 5 years, probably even in two, these four skills will be the difference between people who matter and the people who are replaceable. And you can hear nowadays like the number of layoffs happening in the big companies. Like we're talking about thousands, not only two or three. So, and the good news is that the machine cannot do any of these. Not because they are hard technically, but because they require accountability, judgment, wisdom. AI has none of those. however you do. So let's start with the first one, the constraint thinking. Let's call it skill one. Actually, this is the ability to define before anything runs what the system must never do, what is must always guarantee, and what the mistake here would cost. This is a skill that turns a vague intention into real instruction. So let me give you an example about this. Say you're building a payment feature. You could say to the agent, build a payment system, generate, pay, and the agent will do something. Probably it will create like a payment system. But what is the payment system that it will build? Or you could say, build the payment system, but remember, this cannot touch the customer data, it cannot retry failed payments more than 3 times, and it cannot create a transaction without an audit log. If any of these break, the whole feature fails. Now the agent has boundaries, now it understands what it matters. So this is not to be, don't understand this as being detailed, let's say. It's about being clear on what is forbidden. How, like possible ways to practice this, you can start it now probably. Break your next task before the agent runs, write one sentence. And what sentence is what is not allowed to do. That's it. Just one constraint. They cannot delete user data. This cannot change the schema without my approval. These cannot call external APIs without timeout protection. One sentence, write it down. Like I use it every day. So sometimes I say, let's think about the solution, but don't write any code. Because like the agent, if you don't give this instruction, it will create a code and then it will be hard to reverse what it did. So the discipline of writing this, it forces you to think like an architect, not like a passenger. You are no longer hoping for the agent to do the right things. You are deciding what the right means. So this is constraint thinking. Next, the consequence reasoning. This is a discipline of asking, of actually not asking, does this work, but what happens in 12 months if this is wrong? So we can call it also, it's called post-mortems. So the agent optimized for today, it sees the code, passing tests, it does not see time actually. So an example, the agent sees a solution that is fast, the code works, test pass, but the agent thinks this is success. But an experienced engineer actually thinks, wait, what happens when we have 100 times more data? What happens when we have like 1,000 users instead of 10? And the answer is that will break definitely without anyone noticing that. So, of course, the agent cannot see that far. It optimizes for completion, not for the future. And probably some tips on how you practice this. After any significant decision, write one sentence, or you can use like a lot of templates like A. What becomes harder because of this choice? You are free to use whatever template you want. We choose Postgres instead of MongoDB, for example. This makes it harder to scale horizontally. We choose this caching strategy. This makes it harder to handle cache and validation, etc., etc. Because every choice is a trade-off. Remember this. This is the fundamental rule in software architecture. Every decision locks you into something. It could be cost, it could be time, it could be performance, it could be whatever. The agent does not understand this, so it makes choice without thinking about the weight. But you can think about it, and of course, you should think about it because consequences are real, they happen, and of course, they cost money. Next skill, after we talked about this consequence reasoning, decision visibility. This is the craft of surfacing implicit choices, like making informed decision, naming what was decided, why especially, and what it rules out. So it is something true. Most technical net is not bad code. It is an invisible decision that a choice that was made, but nobody remembers why. So why do you use this database? Who decided? When? Why did we abandon the other approach? What went wrong? Why this is constrained? Is it real or just a habit? Etc. Etc. So actually, here, when the agent comes along, it doesn't either. So it makes the same choice again and again, or makes different choice without understanding the history. So your job is to make decision visible. Write them down. Not only for the agent, it could be for you, like in the future, to probably, if the context and the environment change, you could have another or a better solution. All right. So, of course, this is not extra work for your information. This is the work. This is what keeps a system sustainable and safe and robust. All right. Last skill, it's context authorship. So this is the ability to write the brief that gives any agent or any new person everything they need to act without asking you. Think about the last time someone handed you a work with no context. Just do it and or build this feature. So there is no explanation, no history, no why we are doing this. And you can see that we are always talking about the why here. Of course, it was frustrating. Like it happened to me many times. And you had to ask questions and you had actually to figure out uh, things. What is the missing like requirement? What are meaning by this, etc., etc. Now I want you to imagine that person as an AI agent. You cannot ask question. The agent just does what it thinks is right. And what it thinks is right might be very wrong. So your job is to write clear context, not just what to build, but why to build it, how it fits, and why it matters. So practicing this, like you can always think about these things, why we need, what we need, why it matters, what must not break, what success looks like, and what you must not assume. Like because some assumption could grow the, let's say, the cost from 100% days to 2,000 or more. So be careful with this. So the higher this skill, context authorship, the faster everything around moves because people understand what matters. They do not waste time on the wrong things. This is context authorship. All right. Of these four skills, if you remember them, like constraint thinking, consequence reasoning, decision visibility, context ownership, which one do you already do well? Think about it and why you are strong or where you are strong. Sorry, my daughter. This is life moment. All right. So I ask you again. So for of these four skills, which one do you really do well? I want you to share this in the comment and where you are really strong actually. And of course, the other part of the question, which one would your team say you are missing? Please share that in the comments also. So the gap between the answers, this is your development priority. That's where you need to grow. Not all four at once. Start with the gap, start with what the team is asking for and what they need from you so they are not getting right now. That's definitely your focus now. All right. Another truth. This actually something that will change how you work. The most expensive workflow is let the agent run, then clean up the mess. This is a big lie. So, review, fix, redesign, fix again, weeks of effort. This actually 90 times more expensive than getting it right the first time. And you can see here the highest leverage is 10 minutes in your entire sprint or before your entire sprint uh, before the agent runs. So not after, before. Before the agent starts, you spend 10 minutes asking hard question. What are you assuming here? What could break? What are we locking ourselves into? Like, is that constraint actually true? Just 10 minutes of thinking and of course real thinking, and that's called architectural thinking. And because of those 10 minutes the agent makes smarter choices because you shaped your context, you defined the boundaries, you are no longer the reviewer, you are actually the designer. This is not about working more, this is about working smarter. Spend 10 minutes thinking before, save weeks of fixing after that. That's the trade off. That's the cost to pay. That's how your AI agent will efficiently do the task. All right, let's talk about the five things your agent will never know. So, first thing, the agent thinks I'm writing code, it connects to nothing. And the experienced engineer or experienced architect knows this touches nine other systems, three of them are critical. If this breaks, everything downstream breaks. First thing. Second, the agent thinks this is a good solution, right? And of course, we say, we tried this 18 months ago and it failed in production, and that was a nightmare. So the agent don't know about this. The next thing is the dependency is optional. This is what the agent assumes. I can use it definitely. So, however, if we remove it, we violate a legal requirement. The audit will fail and we will have a real problem actually. Next, the agent thinks the tests pass, therefore it works. So this is how they evaluate something is working or not. And of course, like it can work today, but in 6 months, when we have 100 times more data, it will break solidly without even noticing that. And last but not least, of course, this is a detail or a tiny detail. We can change it later. However, in reality, if we choose this now, we are locked in. Changing it later would mean rewriting the whole system. And it's actually kind of, we can call it irreversible. So, like for example, migrating all existing data, updating all system read write format, etc., etc. So, next, this is we already discussed about this, but this is extremely important. So the agent made 200 decisions, you approved only three. So it means 197 decisions are happening in your system, and you are not responsible for understanding them. But your users are experiencing the results, your customers are affected by them, and if one of them breaks, of course you will pay for it. This is not sustainable and this is not acceptable, basically. So the question is, how do we review more decisions? You cannot review 200 decisions. There is not enough time, basically. So the question is, how do we make sure the important decisions are made well? Because like even choosing like a for loop instead of for each is a decision. How like we can like control things that we can like like can you see me?
Yes, we can continue.
Can you see me? Uh-huh.
Yeah. We can hear you.
Oh, sorry, I continue like lifetime
Okay.
connection problem. All right, so this is basically the most underrated skill that we need to pay more attention to that. So this is the skill nobody talks about. This is naming decisions, spotting risky connections, catching things that will break, showing invisible things, especially, and making the silent visible. So this is the most important skill in modern engineering. And of course, as I told you, it's underrated because it's not about being fast, it's not about being clever, it's about being wise. And how you do it, you ask questions, basically. And here I'm about to tell you like The 5 questions checklist that will help you your day-to-day work with AI agent. First question, what did the agent assume about the rest of the system? So you give it, like, you can ask it. There is a lot of skills now. We can use skills, etc., from the like AI agentic based IDEs, etc. Next question is, what happens when this breaks? So you need to be prepared. So not doing things now, but planning for the future. Because if you do things now, it's over engineering, and you may break the Yagni and KISS principles. But if you plan for it, we call it architecture clairvoyance. All right. So what did it just get connected to? So we need to talk about the system boundaries. And this is something like in the software architecture trainings, this is the context delineation or the context view, let's say. Which decision here cannot be changed in 12 months? So this is about the priority, and this is actually an architecture. This is what will make you differentiate between an architecture decision and a design decision. So if I left tomorrow, would this make sense to someone new? And here we're talking about documentation, like how you create like a legacy, let's say, why you did this, why you didn't do this, etc., etc. The question is for you. If your name was on every decision your agent made last week, for example, which one you own? So please share if you want that in the comment, but make sure that the gap between what you would own and what the agent decided is the size of the blind spot. And this is a real big problem. Your blind spot, so things they are not under your control. It's like someone said, like, this person has done this, you are responsible, but you didn't do that. So before AI here, the role actually didn't disappear, basically, but actually the role of an architect, let's say, it became more important. So before AI or engineering in general, the engineer who builds things, you wrote the code, you made the decision. All right. So then we have assisted AI, the engineer who reviews things, and you guide the output, you approve the patterns, etc. This is the assistive AI. Now with agentic AI, the engineer is the one who shapes the context. You decide what the agent is allowed to decide alone. You hold the memory nobody else is holding. So the question here, like, it's probably a tricky one. What no model will never replace, not because of capability, but because of accountability. Like, first, it is actually memory, and we mean by memory we mean wisdom, let's say. All right. So the things like all the decisions that have been made in the past, the ones that have been rejected, like everything around the system boundaries, the context, etc. Everything that will uh, like also knowing why the system is built this way, including the decision nobody documented, like the vision of the system, the problem, especially the problem it solves, right? So the most important thing is, what is the problem we are solving right now? Next one is navigating constraints. We already talked about this, and of course here you set or the most important constraints that will, so to set the boundary to your system, right? Next one, consequence thinking. Already discussed this. So you think it's called postmortems. You think what happens in the future. And last is taking responsibility. And this is super important. Taking responsibility is everything. So you should be responsible. It's like a leader. You should be responsible for your team. Things that go that's done well, and things, and especially things that are not done well, things that are wrongly done. So how to do this? Like, you ask the hard questions, definitely, and you protect especially what matters because you are responsible, right? All right. So I want you to leave after this. Like, we talked about like some techniques, let's say the paradigm shift, the mindset that you should have. It's not technical. Anyone could like master it. It's like a learnable skill, let's say. So here we talked about words that change how you talk about to your team, and by your team here, to your, could be your managers, could be like product owners, could be developers, and could be also AI agents. And so what should we build? What is forbidden here? This is extremely important. Instead of does it work, what it breaks when in 12 months. This is super important. So the next, the also we've seen the 5-question checklist. So before any AI generated feature, the 5 questions that this alone will save you like a tremendous amount of time, and time is extremely important here. And the last thing is why you matter. In an agent world, your judgment is the product, right? Your memory, your accountability, and especially your wisdom. These are not things that will be automated. They get more valuable again and again. Okay? So every company is going to use AI agents. If not, all of them are doing right now. Most will use them badly and carelessly. The ones that will use them well, the ones, let's say, where an architect is asking the hard questions beforehand, those are the ones that will win. So you are not being replaced, you are being promoted from code writer to an architect, actually, from an executor to a designer, from an implementer to a thinker. That's your path forward. Thank you for your attention.
Thank you, Ziad, for all the insights. That was very interesting. One image that will definitely stay with me is the idea of the agent that is more optimizing the completion, and then us or the architect generally optimizing more for the consequences. And thanks to all the audience for staying with us and joining today's webinar. I hope to see you next time as well. And yeah, my final words are take care and see you next time.
Thank you. Thank you.
Thank you, Ziad.
We are available for any questions, of course.
Thank you.
Thank you so much. Bye.
Bye-bye.